So today we're going to be looking at section 11.3, solving equations by using the quadratic equation. On example 1, we have to solve x minus the radical x minus 6 equals 0. We add the radical x to both sides and we're left with x minus 6 equals the radical x. Then we square both sides, and when we FOIL x minus 6 times x minus 6, we get x squared minus 12x plus 36, and squaring the radical x, we get just x. Subtracting x to both sides of the equation, we find that x squared minus 13x plus 36 equals 0. That factors quite nicely into x minus 9 times x minus 4. Setting each piece of the equation equal to 0, we find that x can be 9 or x can be 4. Plugging the 9 back into the original equation, we get 9 minus the square root of 9 minus 6. It does equal 0. So 9 is a solution. But when we put 4 into the equation, we get 4 minus the square root of 4 minus 6, and that does not equal 0. So x equals 4 is not a solution. On example 2, we have to solve 3x divided by x minus 2 minus x plus 1 divided by x equals 6 divided by x times x minus 2. The LCD, or the least common denominator, is x times x minus 2. We need to take that times each of the terms of the equation, and when we do, we get 3x squared minus x minus 2 times x plus 1 equals 6. 3x squared minus the x squared minus x minus 2 equals 6. Distributing that negative, we get 3x squared minus x squared plus x plus 2 equals 6. 3x squared minus x squared is 2x squared, and we bring our x down. And we take our 6 over to the other side by subtracting 6 to both sides. And 2 minus 6 is a negative 4. Plugging that into our quadratic equation, we have negative 1 plus or minus the square root of 1 squared minus 4 times 2 times a negative 4, all divided by 2 times 2. Continuing to simplify, we find that x is equal to a negative 1 plus or minus the square root of 33 divided by 4. On example 3, we're given the equation p to the 4th minus 3p squared minus 4 equals 0. Factors quite nicely into p squared minus 4 times p squared plus 1. We know p squared plus 1 is prime, but p squared minus 4 is the difference of squares, so it factors into p minus 2 times p plus 2. So setting each of those pieces equal to 0, when we do p minus 2 equals 0, we find that p equals 2. Or if p plus 2 equals 0, then p equals a negative 2. And if p squared plus 1 equals 0, we get p squared equals a negative 1. We take the square root of both sides, and we find that p is equal to plus or minus the square root of a negative 1, which we know is p equals plus or minus I. On example 4, we have a nice little word problem. Together, an experienced word processor and an apprentice word processor can create a document in 6 hours. Alone, the experienced word processor can process the document 2 hours faster than the apprentice. Find the time in which each person can create the document alone. Let x be the apprentice's time. So then we set up the equation that 1 over x plus 1 over x minus 2 equals 6. The LCD for that equation is 6x times the quantity x minus 2. So we multiply each term by that least common denominator, and when we do, we find that 6 times x minus 2 plus 6x equals x times x minus 2. Continuing to simplify, we find that 6x minus 12 plus 6x equals x squared minus 2. Taking all the terms over to the right side of the equation, we are left with 0 equals x squared minus 14x plus 12. Now we're going to use the quadratic equation to solve. When we do, we know it's minus b, and b is a negative 14 plus or minus b squared minus 4 times a, which is the coefficient in front of x squared, is 1, times c, which is 12, all over 2a. Continuing to simplify, we get 14 plus or minus the square root of 148 divided by 2. The square root of 148 is approximately 12.2. So if we take 14 plus 12.2 divided by 2, we get 13.1. Or if we take 14 minus our 12.2 divided by 2, we get 0.9. Plugging into x minus 2, we get a negative 1.1 hours, which is not possible. So 0.9 is rejected as a solution. So our only solution is the 13.1.